formed by two what we call rays with a common endpoint. All a ray is that it has a starting point, but it doesn't have an endpoint. Okay, so here we have a ray that starts at B, goes past A and on forever. Here we have a starting point at B, goes through C and goes on forever. That's all a ray is. In our angles, this endpoint is called the vertex. It's where your two rays meet. The rays are called the sides. And name an angle using three letters. At times when it's only referring to one angle, if there's only one option, you can use one letter. In this case, we could use one letter called angle B. There's only one angle B right here. When we use three letters, big thing, the middle letter has to be the vertex. So in this case, we got angle A. B is our vertex, so it has to be in the middle, and C. So angle ABC, I could also call it angle CBA. When referring to the measure of an angle, we use this little M that just tells me the measure. It's not really proper to say that like angle ABC equals 60 degrees. That's why we use the measure thing, okay? Types of angles, this shouldn't be too hard. We have an acute, that is when it's less than 90 degrees. Obtuse, that is when it's greater than 90 degrees. Our right angle, it equals 90. And then a straight one, it's kind of like two right ones put together. This equals 180 degrees. It makes a straight line. In this case, the vertex of the angle where my two rays meet right here at K, point K. The sides are always rays, okay? They start at K and this one goes on to J. So we start at K, go on to J, and then we make this little like a one-sided line thing. And then our other side starts at K and goes through L. As far as naming the angle, easiest, one letter. If I have one letter to name it, I can call it angle K, my vertex. Other than that, K has to be in the middle, so I can go this way, JKL, or I can go backwards, LKJ. Classify the angle. This is an obtuse angle because it is more than 90 degrees. Example 2, my vertex where my two rays meet is S. My sides, they start at S and go to R. And we got S and it goes through T. Name 3 ways to name it. I got my vertex, angle S. And then S has to be in the middle, RST, and TSR. Classify it, I got this little box thing that tells me it is a right angle. If you're talking about the measure of angle A equals the measure of angle B, so here, if I got two angles that have the same degree measure, then the angles are congruent. We write the little congruent sign. Angle A is congruent to angle B. They are the same measure. They are equal. An angle bisector is a ray that divides an angle into two congruent angles. We had a segment bisector, remember segment, then it came to bisect, and we said that these two parts have to be equal if it comes in and bisects. Okay, same sort of thing. If a ray comes in and bisects my angle, all that means is this angle right here, ABD, has to be the same as DBC. So this angle and this angle have to be the same. So if this is 10, this has to be 10. They have to be the same if we have an angle bisector. And that is always noted with these little arc things, just like we had these line things in our segments. So again, in the diagram to the right, my ray BD, this thing comes crashing through. It's an angle bisector, and it makes angle ABD congruent to angle DBC. Like we said, the thing's marked with little arcs here. Perpendicular lines, I feel like you can learn this in algebra. Two lines that intersect, meaning they cross. Whoa. They intersect at a right angle, or they intersect to make a right angle. Right angle, again, being 90, always marked by our little box. The symbol perpendicular, we use like an upside down T. We don't ever really mark it, you can if you want. In the diagram to the right, we say line L right here is perpendicular to line M here. Again, noted by that box. In line segment or ray, perpendicular. This is why we use symbols, because it is annoying to write out long words. Perpendicular bisector, a line segment or ray perpendicular to a segment at its midpoint. This is basically, like I said, bisector. Before we had, and it made these two things equal, so this equal to this. All we're saying now is that, yes, we have a bisector, but it's also perpendicular. So yes, these are still the same, but we also know that it makes a right angle. That's the only difference. We're adding that perpendicular part. In the diagram to the right, line LM is a perpendicular bisector to line PQ. I know that it bisects PQ because of my little marks that tell me it's congruent. So LM comes through, makes a right angle, so it's perpendicular, oh boy, and then bisects PQ. Alright, back to our angles. I know these diagrams look kind of crazy. Easiest thing to do is to mark them up. I have angle CBF. I know B has to be the vertex because it's in the middle. I need to write another name for angle CBF. Easiest thing to do. I can't just call it angle B because I got this angle, this angle, this angle, this angle. That's all by B. Easiest thing to do, if they call it CBF, we call it FBC. Name the sides of angle E. Here's E, B, D. My sides, starting at my vertex, BE. So ray BE, and then starting at my vertex, ray BD. Classify angle ABC. A, B, C is right here. That is a straight angle. Makes a line. Give an example of an obtuse angle. There are a bunch of them. I'm going to go with EBD. I know that that angle right there is more than 90 degrees. You could also call it DBE. Anyway. Two congruent angles. Congruent meaning that they are the same, they're equal. I have these little arc things that mean they're equal, so I'm going to use those two angles. This one I got CBF. And then this angle here I'm going to call angle EBA. Make sure your vertex is in the middle. And then a perpendicular bisector, the only right angle I have is right here. The only thing that tells me it bisects is here. So BD has to come crashing through here in order to bisect my line AC. So BD is a perpendicular bisector of AC. And I know that because I got my perpendicular and I got my bisects lines. Alright, last example. Vertex of angle 2. Here's angle 2. My vertex right here. T. The sides of angle 4. Here's angle 4 right here. my side starting at vertex T, go to W, so TW, and then starting at vertex T, going to Z, GZ. Those are my sides. Another name for angle 3, here's angle 3. We cannot just call it T because we got a bunch of stuff around T. So we're going to start U, T, Z. Remember, T has to be in the middle because it is my vertex. Another name for angle 1, here's angle 1. Again, T has to be in the middle, can't just call it T. I'm going to start here, Y, T, X. That is really good. Angle YTW, YTW is right here. This little box tells me it is a right angle. Angle YTU, I got Y, T, U is over here. This angle, ooh, I missed a little bit, looks like it's more than 90, so we say obtuse. Angle XTU, right here, definitely less than 90, so it is acute. And angle WTX makes a line, so it is a straight angle. Two perpendicular lines. Anytime you see perpendicular, look for the box. Here's my box. So I got this line and this line. They must make perpendicular stuff, so we say WX, line WX, and line YZ. Because there is a box next to them, they have to be perpendicular, meaning they make the right angle. And then angle bisector, anytime you see bisect, look for your marks. In this case, we got the angle curved ones. So I know that those two angles are congruent, which means this right here has to be my bisector. That's the thing that cuts this angle in half to make the congruent parts. So that is a quick run through of angles.